Okay, let's do problem 234 palindrome linked list. Here we're going to determine if the singular linked list is palindrome or not. So the way we're going to do is, suppose we have 1, 2, and 2, 1. We're going to get the second half and flip it to make 1 and 2, and then compare with the original ones one by one until the end of the second linked list. The most important part is how to find the starting point of the second half. So to do that, we have to find the well, it's not really correct to say it, but we have to find the midpoint. So to find the midpoint, we need to have a fast and slow. So slow will go by 1 and fast will go by 2. And then slow will go by 1, fast will go by 2. So obviously that's the end of iteration. So if it's odd, we can see that fast is equal to is not equal to 0, but fast done next is equal to 0. So this is when we stop. And then let's think about, so that's where the slow is. So in this case, we obviously need to increment the slope by 1 to get the starting point of the second half, because we're interested in getting these two linked lists and then these, and then we can compare with this linked list. So we have to do slow done next at some point. But if it's even, we're going to do the same thing: fast, slow, slow, fast, slow, fast, slow, and fast. So at this point, fast is equal to 0, and then slow is actually in the perfect spot because we're interested in the last 3, and then we're going to compare against the first 3. Okay, so I'm just going to remove this one. So we're going to find starting point of the second half. So what, okay, we need to create a list node of fast is equal to head, that's a starting point. Again, head, that's a starting point. And we're going to use this logic here, and then this logic here. While fast is not equal to 0, and fast dot next is not equal to 0, we're gonna do slow is equal to slow dot next, and then fast is equal to fast dot next dot next. So if it's even, slow would have been placed in the perfect place, but if it's odd, we have to move slope by 1. So what's the condition? Well, we've already seen that fast is not equal to 0 when the iteration ends. So we can say that if fast is not equal to 0, if odd, adjust the starting point. Slow is equal to slow dot next. Now we have to revert the second half. So it's exactly the same as problem 206. So I'm not going to go through it. So we do a list node of second half node is equal to null, and then we have while slow is not equal to null. We need to create a list. Why do I? It's a list node. Temp node is equal to slow.next, and slow.next is equal to second node, and second node is equal to slow, and then temp node slow is equal to temp node. All right, that's reversing the second half, same as problem 206. And then, so we did create a reverse list of the second half, and then so we're going to do while loop while second node second node is not equal to null, and if second node the file is equal to head.file. I'm not going to create like another list node to represent the first half. We can just use the head. Second node dot is equal to second node dot next, and then did I say second node? Oh, it should be second head. But head is equal to head dot next. Else return false, and if this false doesn't get called during this while loop, we can return true. All right, and let's run the test. Okay, let's submit. All right, that's it.